Okay, and we are live. It's day 8 of Advent of Code. Exciting. Um, tree top tree house. Is that another tree problem? Okay, let's see. Yeah. So again, I'm going to keep quiet for the first 10 minutes, and then you know try to solve it. Right. Sorry. Try to read the question, and then when we are done, we can talk about what the question means and how to approach it. Only look up, down, and left. Only look up, down, and left or right from any given tree. Down, left, or right from any given tree. Down, left, or okay, right. This is an product. That leaves the interior 9 trees to consider. Top left 5. He said only look up, down, left, or right. Consider trees in the same row or column. That is okay, okay, makes sense now. Top left is visible from the left, and top since other trees of height 5 are in the same row. The top middle 5 is visible from the top and right. Middle 5 is visible from the top and right. The top right one is not visible from any direction. Okay, so based on this input, the top left 5 is visible from the left and top. Okay, same visible from the right and or bottom. So since other trees of height 5 are in the way, and the top middle 5 is visible from the top and right. Between it and an edge of a grid are shorter than it. Why are they saying the top middle 5? Top middle 5. Okay, the top middle 5 to the right is 1, to the top is 3. Okay, makes sense. Um, the top left middle 5. Okay, is visible but only from the right. Right. The center P is not visible from any direction, for it is not. Yeah. There will be need to be only trees at most height to turn it and the edge. Right middle 3 is visible from the right, and that's about it. In the bottom row, the middle 5 is visible from all angles. Okay, with the 16 trees visible in so we have a problem of visible in the interior. Total of 21 trees are visible in this arrangement. With 16 trees visible on the edge and another 5 visible in the interior. Total of total of 21 trees are visible in this arrangement. Okay, visible, and the rest aren't. But wait, I thought we are looking for totally visible. Between it and an edge of the grid. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. 8, 9, 10, 11. Okay, 16 on the edge and 5 visible in the interior. Okay, so consider the map and then get your, this is a 5 by 1, 2, 3, 4, 5, minus 1, minus 1. Okay. Yeah. Okay, so let's get the puzzle inputs. This was a tricky one to read. Copy. Or maybe I'm just slow. And copy that one, two. Not an idea. Okay, and then I'll open this, and we are ready to roll. Basically, the problem here today is we have been given a grid. So today's problem isn't a tree, even though it is named a tree. A two-dimensional array traversal question. And what that means is that yeah, there isn't much of any processing to be done here. Basically, when it comes to processing the data, it has been given to us as a grid of array and an array. So probably what we could do is make them like a true array of array, right? But to think about it, the strings itself are iterable in the first place. So do we really need to do that? Do we really need to do that? Since we are only going to iterate over them and then count them. Yeah, probably. So let's just do that. Let's just for what am I typing? Yeah, that's something we probably didn't really need to do this because we haven't done anything much to the data. So for this stage, the past data is really almost the same as what we got. But let's focus on the problem. Today's problem is again traversing over a two-dimensional array. And then to do that, we first have to understand what the problem is saying. So given a problem, we are supposed to count the number of visible trees, and the rules for counting the number of visible trees is first of all, how many trees are visible on the edges, right? And basically, um, only consider trees in the same row or column. That is, only look up, down, left, right, right. All of these, all of the trees around the edge of the grid are visible, right? So that's the first rule, right? Which means we have to just count. So yeah, a total count of visible trees, right? And then what we need to do is probably first update it with the number of visible trees from the edges. And how we can do that is basically by doing n minus 1 squared, right? Which is the size of um, um, the array. Wait, if it's an even array, then we can do square, but if it's not, then to be n minus 1 times n minus 1, and so where n is the size of of the the rows, and then the m is the size of the column, right? Um, yeah, and so this should give us the visible edges, visible trees from the edges, right? And then now to the serious part of now following these rules. And this rule says, okay, now starting at the interior, right? At the interior level, just be looking around the four neighbors of of each how do you call it, each element, right, in the interior. So basically, start a for loop which starts from array index 1 1, right, all the way to array index n minus 1 to n minus 1, right? So and then as I am doing that, all I need to do is be comparing the edges of so scan the edges and see um, if it meets the scan edges and see if it meets the the criteria for visible. And visible is so long as there is one tree on the neighborhood which is less than it, right? It's visible from the left and top. It isn't visible from the right or bottom, since other trees. Yeah, and so yeah, this is not total visibility, right? This is just partial visibility, you know. And so scan the edges and um, if a neighboring tree is shorter than I, right? And yeah, that's basically it. If it is, then we increase the count. Instead of writing that in full, let me just write it in pseudocode. That's going to be visible, total visible. I really do that. Plus. And yeah, then finally we just return the visible count. Okay, so let's start doing that. And so yeah, we basically need an, an, an ij loop, and then for j in range right. Once we have that, we can basically start doing the fetching, right? So we say but it shouldn't run from the top left to the it should run from 1 and end at n minus 1. And this one should also start from 1 and then end at n minus 1. That's literally what we agreed on. Yeah, and over here, what we want to be doing is be peeping at the neighbors, and basically how we peep at the neighbors is the left will be -1 there, right? So um, I'm hoping that's how to spell neighbors. The neighbors are going to be um, let me just do it in multiple lines so that it becomes a lot readable. Input data into square brackets I -1. That will be the left, and J. Same thing goes here. No, yeah, left is going to be this. And this is going to be the right. Um, let me just copy and paste it. I really don't want to be typing it. Yeah, and for this one, it's going to be I -1 and then J. That will be the top. And this will be the bottom. And so once we have computed all of these neighbors, they can be put into this list of neighbors here. And once we have our list of neighbors, all we need to do is check that there is at least one which is less than the current tree, right? So if um, for neighbor how do you spell neighbors? Yeah, if there is a single one, so if neighbor is less than me, and then I am going to be input data into square brackets I into square brackets J. That's who I am. Yeah, so if I find one single instance, I should basically just um, increment the total visible, and then exit. But before I exit, I probably shouldn't continue. Okay. And then when I'm done, I can return yeah, so this is basically my function, a very simple one. I have made some typographical error here. Let me see what. Okay, I really don't need this, so let me minimize this bit. See what I've left out. I've left this one out. Okay. Yeah, and so basically that is it. Let's see what I've left out again. Right, I didn't separate the items by commas. Okay, so let's run this. Wait, I think maybe I have left more things out. No, I mean minimize. Yeah, I mean that's about it. Very, very, very simple and straightforward. I'm sorry, I didn't copy over the. This one was supposed to be 21. For the test inputs. Okay, so yeah, I obviously didn't strip the trailing. Trailing new line. Okay, I got a 6. Yeah, that's because I skipped this whole part. This whole part. And then why am I getting a 6? I'm supposed to be getting a 5. We'll come back to it. N minus 1 plus. So let me write this one down. Instead of starting from 0, it should be um, this is n minus 1, and this is m minus 1. Um, yeah, I'm supposed to be getting 5 for here, but I'm getting 6. So let's see why. Yeah, I think what will be best is if I print out what I am saying it is a visible neighbor. Okay, so let me print out the actual number. It's going to be this, and then print out the corresponding position that I have found it in. Okay, and I can expand this. Look at y. Okay, so it first found 5, 5, 5, 3, 3, 3, 5, and 4. Okay, and we are supposed to be looking for 5, 5, 1. Yeah, 5, 5, 5, yeah. 3 comes, yes. Center 3 is not visible. So why am I getting visible? Let me see. Center 3. Okay, this is the 3 from position 2, 3. From position 2, 3, 0, 1, 2. This is, yeah, so 0, 1, 0, 1, 2, and 0, 1, 2, 3. Okay, so yeah, this 3 is valid, and this 5 too is valid. But why does it give me a 4? This 4, 3 and 4 are not. Okay. What? What? Um, each tree is represented as a single digit whose value is not 0, 9 tallest. Tree is visible if all the other trees between it and the edge of the grid. Between it and the edge of the grid. Oh, I see. I see. I see. I see. I see. So not just top, throughout to the edge. Okay, I see. Then the neighbors has to be scrapped. So 4 is not visible because 5 is here, 9 is here, 9 is here, and then 7 is way up there. Right. So only consider trees in the same row or column. That is, only look up, down, left, or right from any given tree. Okay, so let's confirm that theory. The ones which are visible, 5 is 5, 5 also is 1, 1 is not 5, left middle 5, yes, 5 is because even though it is not here and not here, it is here to the right. Okay, it makes sense. Yeah. So a slight pivot. Instead of just looking at one value to the neighborhood, we should look at all the way through to the edge, right? And so what that means is that this has to change, right? This this simple way of calculating the neighbors has to change. And so basically what has to change is we have to build the neighbors afresh, right? And how we are going to build it is build the left separately, build the right separately, and then basically join them as one list in here, right? And so um, yeah, and so let's write a, a dummy function which basically takes, doesn't necessarily have to be a function because I only need, oh, I see. If I traverse over here, yeah. So let's get that down first. So given a position I and j, it should look at see if it is greater than all the values in that array, right? Yeah. Okay. Um. Okay. So how about after we have located an index, we do this loop too as well. So we So we say first of all, let me comment this out. This is no longer needed. And what I need to do probably is over here. What I'll do is for that would be some. So you select the row and then see if there is anything in there less than it, right? And then you select the column to see if there is anything less than it, right? Um, yeah, definitely do that. Yeah, I can't use this thing here. And so what I've got to use is basically a method, right? Write a method which takes in a position xy, define. Let's call it um, is visible. All right, that just takes in position xy, and what it does is that um, it traverses over the input data. Let me just call it array. Right, it traverses over the array and then tries to find if within that row there is anything higher than that, right? So or have an idea. We could probably transpose this and then save it as rows and columns so that we don't have to be doing that nasty ass loop, right? Um, yeah, yeah, that's a far better solution. So let me transpose this over here. How do I transpose this very easily without having to use NumPy's transpose? I mean, the way I know how to do it is to use NumPy's dot transpose like method on arrays, but if I have to write it, That's going to take time too. That isn't it? If I flip IG, yeah, 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 yeah. I'm thinking of how to just create the size to be the inverse of the size of. So if this is going to be, let's see, a 4 by 10, right? We want the 10 to be on the inside. So creating, yeah, and the 4 to be on the outside. Okay, and then over here, just check to see if in the rows and columns. So instead of using the neighbors, right? You check to see for. So you have to first select the row in which this particular element selected is on, right? Once you have that row, right, then you can check to see if there are any numbers greater than that on it. So basically, instead of using neighbors, what we can do is pick any of them. We have I and J, so we check to see if the I and J copy. Okay, so we have to first check And I do select 0, which will give me the first row. So among the rows, right, so on the rows, it's less than. Can I do this? I just had an idea. Uh, this shouldn't be allowed, right? This is so Scala. Yeah, this is so Scala. Yeah. Anyways, that would have been nice. Um, yeah. So what I wanted to do is pick a row. So for in row, right? If we can find any number less than my current tree, right? We can increase the thing and then break the loop. Basically, what we were trying to do here. I think we might need our print for debugging too as well. Real soon. Copy, paste, and then do the same thing for let's say for now in current tree. Sorry, for now in row. Rows, no rows. To square bracket, let me select the I, right? Because that's what we are dealing with. And then same thing for columns in J, right? This should probably again be a function outside. Wait, if we find one less than, no, here's supposed to be, oh boy, oh boy, oh boy. I need to slice this from the beginning all the way to where J is, right? And then check if yeah, this should probably be a function. It should definitely be a function, not probably, definitely. So, it takes in the positions x and y, and then the entire whether row or column, right? Let's call it array. And basically, what I will do is that based on um, the array, I will look to the left of it and look to the right of it, and if there is any value, right, that is. So let's split it to left and right. Yeah, all I need is for one value to be less than it, right? Because itself won't be less than itself. So let me just copy over this part to it. And whether it is to the left or right, we really do not care. And we don't need to do this too as well. And we don't need to do this too as well. Yeah, so long as you can find one thing instead of doing this and printing this, if we can find one thing, we say return true, right? And else return false. And so we can call this, where is num coming from? um, and so over here, what we can do is, check if is visible this number, right, on the rows I or on the columns G. Then we can break out of this, no, not break, just increment the count so you can see total visible counts, right? And then move on to the next number. Um, yeah, and so this should be totaling to our 21 now. I didn't exit my Python editor. List indices must be integers or slices, not list. Why am I passing in a list? Oh, yeah, and again, this should probably be some variables outside because I am writing it way too many times. Okay, what else? Yeah, I'm doing it over here too as well. What do you mean current tree is not defined? If num is less than current tree. Did I really do that? Okay. Again, why are we back to 8? We have already done. Yeah, why are we back to 8? Total visible is what I'm using, right? This should at least be 16. If anything. -1. What? How do I have -1? N is length of input data, M is length of input data 0. I'm doing n minus 1 times n minus 1 and I'm getting -1. What the hell? What the actual hell? And so 5 minus 1 times, oh, I see what's going on. Okay, so 16, and we are getting 25 instead of 21. Okay, so now let's debug. Let's debug what's going on inside here. After the 16, let's be printing out what we were printing out initially. So we print the current tree that we think is visible, and we print its position I and J. Nope, 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 nope. Okay, so we think 5, 5, 1. How is 1? Okay, let's first have a look at the columns. I'm coming. Let me just modify this data slightly, just so I have a clearer picture of where it is being formed. Or probably not. Let me do this instead. Let me print the columns after we have populated it. Okay, so it's supposed to give me the columns. 3, 2, 6. No, 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 no. 3, 2, 3, 2, 2, 9, 0. What's that? 3, 2, 2, 3, 2, 2, 9, 0. Yeah, that is a column. Oh, it has been done in reverse order. 3, 2, 2. Right. Oh boy. 32290 322. Why do I have it multiple times? Okay, 32633 24 20. Okay, at least we have the columns properly listed out. 32633 05 535. Yeah, this is properly, yep, selected. Okay, and so let's see why now. 5 5 5 again, 5 5 again, 5 at position 2 1, position 2 1, 5 at 1 1. Yeah, sorry, 0 1 2 2 1. How does this meet the criteria? I want to understand. Okay, this one does. This is the top middle 5 from the top and right. Okay, 5 5 5, and then 3. Okay, there are way too many threes. So this one is saying that the 3 is not visible from any direction. The center 3, this guy right here, is not visible from any direction. This guy is not supposed to be visible. So why are we saying he's visible? Um, if if okay, the right middle 3. Am I selecting the wrong row or column? Let's see. 65332. That's the it enters right away. 65332. Right, so this logic is clearly flawed. I'm checking to see if what I really need to check if there is one case. Yeah, what I really need to check is see if all the numbers to the right are less than it, and all the numbers to the left are less than it. Right, and uh, so what I need to check. Um, what I really need to check is split the array into left and right, right? Which means instead of passing the num, I need to be passing the position, right? Oh boy. And then in here, what I need to do is modify this function to move from num to a position, right? And what that means is that now um, our slides all the way to the position and check to see if I is greater than all of them, right? For I in this, if my I, check to see if the 3 that I have is greater than everything. So if array dot position and do the same thing for the right hand side. Now why can't I just do it for everything? Yeah, I could just pop it from it and then just check it, right? I'm sorry, what? 16. This is ridiculous. Have I flipped this like around? What I had earlier were the rows, right? For 322, was this 65? Yeah, it was the row. So this one selects the row. I need to pass in J rather, right? Because yeah, yeah, this is incredibly shit. Let me just pop it out of it. Array dot copy. I'm hoping it is copy here. If there is one. No, if num is greater than all of them, right? Yeah. It's horrible. I'm horrified. uh, for I in this if array and starting from the left all the way to where the value is. If you find anything that is, if this value is less than or equal to any of the name, just return false. For this one too, if any of them is. If my value is less than or equal to any of the values I'm encountering, right, return false, else return true, right? And yeah, and it's clearly skipping something. So it's going straight to 16. Let me put some print statement here. Probably disable printing the columns after it has been generated. Let's see, 5 in this one, we know. 5 in this one will be no. What am I writing? I'm just supposed to check left and right. If it is greater than, oh, we assume it is visible. If we find anything, set to false, set to false. Silly, silly me. The number is less than or equal to any number at all. Set it to false. What am I doing? I want to check from the left, from the edge all the way to the number, if there is any number that is, it's not any. That's my problem. I keep thinking of any. If all of the number, right? Um, I'm saying for try to do it if any of them is greater than this. What am I doing? I'm overcomplicating things. Let me just visible left. That's true. So basically, if the number is greater, less than or equal to any of them, set it to false, right? Because then it will not be visible. And do the same thing. Oh boy. Can't believe such a simple thing can. Yeah, and then when you are done, just compare this or that, right? What am I printing plenty like that? Okay, this shouldn't be running that long. Okay, I have clearly broken something. Or maybe no, it is done with the first one, so it is doing the, so it passed the case and then copy. Silly, silly, silly me. Oh boy. Let's mute the data for this for now and just run it just to see our outputs. Okay, 21. 5515 5515 3 551 55153. 1 is not. 5 is and 3 is not. 3 is okay, so 1 is not. So why is 1 inside my things over here? Let's see why. Why is 1 over here? The one from position 1 and 3. 1 from here, so exactly this one. Yep, that's the one. we need to find out y. So let's look at I, J. Okay, so we pass in what and what to what's called with rows 1. I'm sorry, what? Why is 1 being called with position 1? Okay, when 1 is called with this array, we should give it 3, not 1. Yeah, so when we call rows 2, 5, 5, 1, 2, we should give it J, not I. And when we call with the columns 7, 1, we should give it I. Yeah. This has been a long time coming, and I think we have finally clocked it. Okay, so now we can uncomment this part and stop printing these two. 11013. Yeah. Again, let me test this one out real quick. My suspected problem wasn't the problem. As to why it's failing, now I can't seem to debug. Let me debug again. Okay, me are getting 5, 5, 5, 5, 5, and 3, 3. 5, 5, 5, 3, 5. 5, 5, 5, 3, 5. So it is working. Oh boy. Oh boy. Oh boy. We have gotten a case where we really, really dreaded, right? Where we can't seem to debug what has gone wrong because we have written the logic according to the rules. 5 is visible, 5 is visible, and we found all the 5 which are visible, right? Um, but when we try to run it against the test input, unless I didn't copy the test input right, sorry, the input itself, then something goes wrong, but I did copy the input right. Starts from 1, ends at 1, 1, 2, 1. Yep, that is exactly the case. Um, yeah, when I pass in this, I was expecting to get this back, but apparently it is not. So yeah, so maybe I should have muted my print statement. I hate this. 11013 was what I was going for. And boom shakalaka, just like that. It is not what it's supposed to be. 1010, that's exactly what the columns is supposed to be. 102 all the way to 0, 0, 0, 1. Yeah, the columns are perfectly alright. The columns are perfectly alright. Rows, everything seems to be alright. Maybe I'll wait for checking the visibility. We still don't understand it properly, but then from my understanding, it is not visible from any direction. For it to be visible, there would need to be trees of height 0 between it and then the edge, right? So if I find anything that is remotely, I am less than or equal to it, right? So on the left, if I find anything that I am remotely less than it or equal to it, set it to false, right? And break. And if I find it, same thing for the right. If I find anything that's less than or equal to it, check out the stream. No no comment whatsoever. Okay. I hate cases like this, right, where the base case that has been the test case that has been given to us is being passed, but then the actual inputs is being filled for. Along a row or column. So I'm doing exactly that, and I'm check. I return whether it is saying of course we assume it is visible from all angles. Then we check to see if there is any tree taller than where I am, right? So if there's yeah, so if I find any objects in which I am shorter than along the path, right? Then we say we are not visible from that path, right? So we are not visible from here. We are not visible from here. But for it to be visible, it just needs to be visible from at least one of the sides, right? So yeah, if it's visible, yeah, then this must have set it to false, right? If it's visible from here, but not here. Oh boy. Oh boy. Oh boy. I am really going blank on this one. Um, yeah, I am really going blank. I'm really going blank. Let me stop printing the columns. This is getting my stuff. Let me set a breakpoint over here. Right. And then run this in debug mode. And what I probably need to be looking out for is every time that function is entered, it's probably going to be entered a lot of times. I explore to see, yeah, special variables functions. Even though I expanded that array. Visible left position is 1. Position that we are using for this one is 1, 5. Visible left is true. So this function returns true. All right. No, no. This is with the second case. Position that we have been given for this is this 2. So we've checked visible left and visible right. The visible right is true. So return visible, right? And that means we count this as visible too as well. So 5, 5, yes. And the next one is obviously going to be the 1. False, false. Right, and so this part is skipped entirely. So we are doing it right. We are doing it right. 3 at the center. 6, 5, 3, 3, 2. That's what we're after. 6, 5, 3. 5, 3. Which one is that? Which one is 6, 5, 3, 5, 3? Huh? Okay. Yeah, something is broken. Something is definitely broken. 6, 5, 3. No, 3, 5, 3, 5, 3. Uh-huh. That makes sense. 3, 5, 3, 5, 3. Yeah, this is what they're trying to refer to. Yeah, this is false, false. And 6, 5, 3, 3, 2. This is supposed to be false, false too as well. It says the center 3 is not visible from any yeah, this should be returning false. If I am less than or equal to visible left is false. Come, let me restart this again. So it goes the row first, then the column. Right? I think I should probably do this too as well. This is where it gets tricky. This thing here is visible, right? The right by door 3 is visible, yeah. Yep, yep, yep. Everything checks out. Everything checks out. Everything checks out. Um, I may be missing something. I'm going to take a break and then circle back. Um, because it's been 2 hours and I haven't still been able to solve problem one. Problem one. Can you believe it? Yeah, so 511. Give it one more last debugging trial. If I fail to cut it, that means bro. Um, okay, so we've captured this. And the second 5. Okay, that's good. And the third 5. We should move on to the middle 3 now. The middle 3 shouldn't. So 1, 2, and then we should move on to the next 3 now. This one should. Okay. And we move on to the next now. Just this 3. This 3 is not. So 1, 2. Okay. And then the next thing that we do. The 5 should be, and the rest shouldn't be. So this was for 4. This was for 4. And then we are done. Right? It's going on again. After the 21 was printed, what was this for? 211. This is for the main data. I do not want to do that. And I do not want to do this one too as well. And this one too as well. This one too. Unless my computation for the outer ones is off. um, I didn't really think about it, but thinking about it now, if I have 10 rows and 6 columns, how many things are going to be on the edges? Isn't going to be this 4 minus 1 times, oh boy, oh my dear. If I have 10 and then 5, right? Let's say something like this. The size of the edge is going to be 1, 1, 2, 3, 4, 5, and 5 here, and 8 in between, and 8 in between. So that's going to be 16 plus 20, 26. 26 definitely isn't Yeah, my bad. I am calculating for area peri instead of perimeter. Um, yeah, this is funny. Yeah. So yeah, like a bag this silly has taken me. It's supposed to be n plus n, right? So 10 plus 10 plus m plus m minus 4. That's the 4 size. So it's supposed to be 20 minus. Oh boy. Yeah. Oh boy. What am I doing? This is completely ridiculous from me. Like completely ridiculous. I'm supposed to be calculating the completely ridiculous. And I was so focused. I think I saw it 1801. Completely ridiculous from me. What is next? I bet they will say instead of just looking at up and top, look at all the edges. Part two, middle five in the second row. To measure the viewing distance from a given tree, look up, down, left, right, and stop. So they would like to be able to see a lot of trees. And so stop if you reach an edge or at, at the first tree that is the same height or taller than the tree under consideration. If a tree is right on the edge, you can see one tree. So now consider this middle 5 tree looking left, and its view is blocked immediately by this um, of height 3. Okay, yeah, how high it is, you can see. Okay, you can see one tree there of height 3. Looking left, it can see. Looking right, its view is not blocked. Looking right, its view is not blocked, so it can see 1 and 2. Looking down, it is blocked down. It can see 2 trees, 3 and 5 until it is blocked. Then the tree of height 5 that blocks right. So it can see 1 here, it can see 1 there, it can see 2 here, it can see 2 here. All right, so until it is blocked, right? Same thing for here, considering this. So for a visible tree, we have to also do something extra, which is counts, right? Okay, so we look here. This one is blocked by looking up, it can see 1, 2. Looking left, it can see 2. Looking right, it can see 1, 2. Looking down, it can see 1. So it's going to be 2, 2, 2, and 1. Okay, so you find the product of that summation. Okay, that one makes sense. So basically, for part two, they have extended the problem to say after we have found a visible, consider each tree on your map. What is the highest scenic score? So this is not even about. This isn't even about each tree on your map. Yeah. So this one isn't even about the visible trees at all. This one is all about starting all over again and trying to compute how many, like the scenic score. That's what they are calling it, scenic score. Um, I don't know what its value is going to be yet, so it's going to be that for now. Basically, we basically have to iterate over each of them, starting from, must the tree not be visible first? I'll just need to know the best spot to build tree. The elves don't care about distance trees taller than those found by the rules above. Okay, calculate scenic score for each of them. So basically, we have to iterate over them again, do the same process and check the top, left, right, and yeah. So let's do that instead of this whole place gets repeated. Instead of is visible, what I would do is so I'm building the rows and columns, um, and then you can copy over the NMM. Let me copy them over. Yeah, and instead of calling over the and this one, the edges don't really matter, so we can afford to start from 0 all the way to n. Right. Highest scenic score instead of scenic score, let's say highest. So what I need to be doing is that for each of them, I need to be calculating the scenic score for each of them. And I need to call it the same way that I'm calling these functions. Um, taking the rows and then the columns, right? So ij and then return back the, let me minimize this. This is define function. How do I oh VS Code, so primitive. So yeah, let's put our utility function right here. Let's call it same name. It takes the I and J and then the row and then the column. And how we to do that is by first looking up, right, to see how many trees it can count. Um, it can't see anything, then it's definitely going to be um, a 0. Yeah, so let's start. Let's look at the top of the row first, right? Yeah. So I'm going to be giving both the right. I'm going to be giving both the and then basically over here I have the height, I have the positions, right? So I can look up, down, right? So given the let's do up. Yeah, so given the row for up, sorry, column, I have to basically just split it from same way as I did this one. Basically, the is visible, right? It should be a for loop to the middle point for all the way to yeah, so all the way to I. Um, looking at the top all the way to where the number is, right? So I should count how many I can see. And this should probably be in reverse order because you actually want to see how many you can count from it. So why not, step into it from the back, right? So that's you know that you are counting. Um, and so you say up count, right? You keep increasing it by one if you have to do the if check first. If the key that you have is shorter than my current height, yeah, if it is strictly shorter, right, then we can increment it by one. And then continue to the next one. And we can check else if it is less than or equal to the height, right? We can increment it by one again, but here after incremented we break, right? And if it is the case where it is greater than, right, which is the else case, the k that you have is just greater than the height, right, then you don't increase at all, you just break the loop, right, and then return the like this should be a method that takes in the column and then the key that we are going, sorry, and then the height, because if not we will be doing it for this, we will be doing the same thing for down and right. Yeah, and same thing goes for the left, right? Same thing goes for the left. The left is going to be the same thing. Right, the left, but this one uses the rule, right? So yeah, definitely this should be a function. Yeah, yeah. I'm just feeling lazy right now. Let me just make this one view counts two for the right and bottom. So for the right and bottom, we want to just count from position plus one, right? All the way to the end, right? Incrementally, okay? And that is going to be bottom and yeah. And so when you are done, you just have to calculate the score as the product of up left. I don't need a lot of these bogus lines because they are doing the exact same thing. Okay, and so this is supposed to return what? Let's mute the input data from the inputs and just run it for the part one. I'm not running part two, am I? Mute all of these and that's okay. Now this is wrong. 2212. Oh, the highest one is 32. Is it? Which one is that? Let's see. How can you have a score of 32? That's everything. Like maybe you are here, so 2, 4, 6, and 8, something like that. I mean, but we just have to confirm that the senior score of this 5 here, right, is 4, and the senior score of this 5 here is is 8, right? So let's, whenever we, during the part 2, whenever we encounter a number, we can just print it out. After calculating the CNF score, we should print the number, so the current tree height, and the position that it is found in, and then also print out the score. And run this and look for the this one is 0 1 1 0 1 2 2. Look for the items 1 2. Okay, this is incredibly wrong. So 1 2 is saying 12. Why is 1 2 saying 12? Let's look at the left of it. Okay, so let's look at the calculation again. We pick the column, and then we look at the things above it. And how we look at the things above it is we have the I and J. The I is Y position, right? Yeah. Yeah, that is Y axis. So with the column, let me say up to 1, right? And so we are expecting to be working with 353, and we go into the view counts, right? And so when we get here, we are saying that from and be moving backwards. I'm curious about something. Right then, let's create a dummy list first. 3 5 3 5 3, right? And then try to do this thing on it. Where the position here is 1. Okay, and assign this thing to A. Let's see what A will contain. Okay, so clearly this is absolutely wrong. It's slicing from the beginning all the way to 1, and I am stepping by -1. Oh, that's how slices work. The step starts before the oh boy. Oh boy. Yeah, so it means we have to change our logic. Then this has to be something like maybe something like this. Yeah, this probably has to be something like from the beginning all the way to 1, right? That's what. And we want -1 start from here. This one was the stop value. Yeah, we don't want it to stop. We want it to go all the way. And we want, so this one becomes a stop and this one becomes a start. Yep. And so this is exactly what we are looking for. Let's run this and then look at the A. Yes, 5-3, exactly what we are looking for. And so here, that means this logic that we have written here should be working this way rather. And this logic that we have written here, no, this is normal. But it is behaving normally, so we don't necessarily have to touch that. So let's run this. Oh, I didn't exit my shell. And let's look at 5 now. Okay, now it is saying 2, which means at least we got some parts right. The this is 1 2 right here, 1 2. Yeah, it is saying 2 instead of 4. Let's see why. Okay, so we got something wrong. The starting point is always inclusive. We don't want the starting point to be inclusive, do we? So it's supposed to be, what if it is 0? Right. Yeah, I'm just wondering. Sorry, plus 1. Again, let me come back to the console. When we did this, we saw that A was being sliced from the back all the way to, and how will I know? Right, this is so stupid. I should have done 1 2 3 4 5 3 5 6 6 7 8. That should be enough. 8 7 6. So it's slicing it from the back, right? But what we really want to do is slice it. First, move it from the back and then slice this part. So basically the ending point becomes the beginning, and the starting point should be now set to all the way to 1 when you are moving backwards. All the way to position 1 when you are moving backwards. So this is ridiculous. I'm still supposed to slice from the left and then turn it around. Yeah, I am overcomplicating this. Slice it from the left all the way to 1, right? And then, well, let's do for 2. And then reverse it, because that's going to give you a list, right? So you can still do this on it. Ah, what am I really trying to do here? Let me see. I was saying I have 3 5. I want just 3, right? Or if I have it, I want just 3 5 backwards, right? Yeah, backwards. So you want to, yes, yes. So this is what you wanted to do. You want to do it normally, and then when you are done, slice it backwards. That's really what you want to do. And for the rest, you leave it as is. It's not going to be really affected. Okay, so now let's see what's happening with the 5 at 1, 2. It is still giving us a 2. Right was good, and bottom was the problem. So right using 1, 2 right on the row. This is it. On the column, this is it. So yeah, the column is counting 1 instead of 2. Why is that? Yeah, why is that? Let's investigate why. First of all, let's ensure that the proper value is being passed to the rows and column. I mean, obviously, rows and column have been received here. Let's look at the calculation for the bottom. So we say height J and column. The position of it is the J. No, Position of it should be there. The I rather, not the J, not the J. If I give you a column, right? If I give you a column, I want to give you the I rather, the position. Yeah. So column goes with I, row goes with G. Yeah, that is my bad. Yeah, let's look again. Okay, 4. So it seems to be working properly now. Yeah, so let's mute the print statement. And then now run it for the case of this now. I didn't mute another print statement. Where is it? Mr. Print, where are you? 009880. That's a very huge number. Wait, I didn't confirm if it works for, oh boy. I only confirmed for 5. I didn't confirm for the other test case. Which is supposed to be this one. Is a 5 at position 0, 1, 2, 3, 0, 1, 2, 3, 2, 5 at 3, 2. Okay, now that's a problem. Oh boy. All right, so 1, 1, 2, 2. That's checking out. And for the other 5, which is 5 at 4, 1, 0, 1, 2, 3, 0, 1, 2, 3. Is there any 5 on 4? Hmm. Yeah, there is a 5 on 4. So not here. The one before you. 5 on 3, 2. Yeah, this one I'm looking for. This one brought out 2, 2, 1, 1. There is something wrong with the last one, which is supposed to be the up, left, right, bottom. Up, left, bottom, right. Bottom, right. Yeah. bottom was 1 and their right was 2. Bottom 1, right 2 minus I can't tell which is which. Let me just order. Okay. So 3, 2, right. One says 2, 2, 1, 1, which means the right is 1 when it's actually supposed to be 2. Let's see, it's supposed to be 2, 4, and 9. Okay, let's see why it is not. So let's look at the bottom calculation again. This bottom calculation is being problematic. This one uses count 2. Count 2 says, first of all, I'm passing in the column, right? Column, and then which means the data it should receive is supposed to be 3, 5, 3, 5, 3, right? Okay. And then if you slice from the position plus 1, the position that I'm passing is I, is 3. To the end, I'm supposed to get 2 stuff, right? And then in that 2 stuff, you have 4 and 9. So if the k is less than the height, I do that. I go to the next one. If the k is less than the height, I increase the count by 1. And then I break. And I return counts. Right? So why am I counting 1? Okay, let's debug this one over here. Okay. So if I have 4, 9, and the height is 5, how am I, yeah, this is 4, 9. How am I not getting to, let's see, it enters it says 5 is less than, oh, oh, no, wait. Yes, if the number is less than me, 4, yeah, 4 is less than me. So I increase it by 1, And if it is not, and then it is less than or equal to me, right. Yeah, the thing should have just ended right here. Okay, now it seems to be working. All right. That means the same thing goes for here too as well. Instead of just checking to see if it is less than it, check if it is greater than, which means the else case should happen, right? Then over here, what I can do is do this, or not with there. Yeah, and then now mute all the print statement that I was using for debugging. Make sure all of them is muted. Then now run this just to see the 8 printed. Beautiful. And now I can turn this on and run this. Okay, 209880. I sure hope this is it. 209880 should be it. Okay, let's look at the leaderboard. This might be a very terrible day to look at. Again, right? Oh, that's strange. Okay, yeah, that's super strange. Okay, so it seems it wasn't so bad after all. All right, so see you same time tomorrow. Come and watch me struggle again tomorrow. All right.